Monday, March 30th. We're continuing our discussion about intertidal ecosystems. And in fact, we'll finish this today. So we talked about these couple of different intertidal ecosystems that revolve around flowering plants, salt marsh grasses and mangroves. And now we're talking about intertidal ecosystems, not in very much detail at all, but that are set aside physically from the rest of the ocean. So if you go around the ocean, there's a lot of small bodies of water that are set aside from the main part of the ocean that would qualify as lagoons. And some of these lagoons, they're not really big enough to be an estuary. Some of them don't even have an input of fresh water, and it's more of a physical separation from the ocean where there might be a dilution of the salt water so that it's a little less salty. Some of these lagoons are hypersaline because of evaporation and the lack of input of water from the ocean. But they're small areas, and yet they have different type of physical features. They have different type of biological features that are associated with them. So if you look in lagoons, it's an area, the productivity might not be changed much at all, but it's certainly an area that organisms can obtain shelter from the open ocean, maybe the water movement, maybe predators. So if you look there, you find different types of organisms there. It's shallow, so some places there might be enough photosynthetic organisms to contribute some higher level of primary production, but that's not the main part. Some of them, there's an input of fresh water, as I said, so it's more like a small estuary where there's brackish water, but some of them are just physical separation from the rest of the ocean. And some places they have mangroves that are surrounding them. Some places they have reeds or some of the plant characteristics that you find around estuaries, bigger estuaries. But it's a protected area with less water movement, so you find some smaller fish, find some fish that are taking refuge, find some organisms that are taking refuge. It's really not so much of an ecosystem, a big ecosystem like these other ones that we're looking at, but it's influenced quite a bit by the tides. When the tide comes up, the lagoons fill up. When the tide goes down, the lagoons have a lot less water in them. Organisms there deal with those changes and take advantage of it and have to tolerate those changes as well. Now, when I was a kid growing up, everybody used to come home after school and watch Gilligan's Island. It was a very popular show back then. Some of you have heard of it, I'm sure. It was filmed in California, in Hollywood, Los Angeles. But they had this lagoon where all kinds of different things happened. A bunch of people would show up there, a bunch of things would float up in the lagoon. It was a big part of their filming. One of the reasons why I was so interested in marine biology as a kid was this lagoon in Gilligan's Island. So that's what I think of when I hear lagoon. An intertidal ecosystem that's similar in a lot of ways to lagoon is channels. There are a number of channels. Most of these channels, not all of them, but there's a lot of channels that have an association with a river. So this river might not come into a body of water that's separated from the ocean and form a proper estuary. Some of these channels are really just deep portions between islands and within sand flats and those kind of things. But these channels, they have water moving through them. They're separated physically from the rest of the ocean. Sometimes they're diluted by fresh water, so it's similar to a lagoon in some ways. But there's a lot of organisms that you would find in and around channels that you wouldn't find just a little ways away out in the open ocean. It's a protected area, and it's a shallow area. Some places there's maybe more productivity, but there's a lot of the periphery of the ocean, different places. It certainly doesn't contribute to very much of area, but there's quite a few channels around. And as I said, some of them are associated with rivers. Some of them are just cuts that run through the land around an island or on sand flats. So it's not a big contribution to the total area of the ocean, but it's an area that has its own physical characteristics and associated biological features and organisms that are found there and take advantage of areas like channels. Well, the type of intertidal ecosystem that there are a lot of are sandy beaches and rocky shores. So let's start talking about sandy beaches. Now, we've looked at zonation. We've looked at zonation in terms of this moving from the water to land, or moving from land towards the water. That there's this gradient of physical features that's translated into a gradient of biological features. And as you move away from the water, it gets harder to live there. As you move towards the water, it gets easier to live there in terms of physical features, but it's more difficult to live there in terms of biological interactions that are taking place. With the sandy beach, this is one of the few marine ecosystems where you have horizontal zonation, like we'll see with the rocky shore, and we saw with the salt marshes, and see with seagrasses. This horizontal or flat zonation is moved from the water onto land. But with sandy beaches, we'll see the same thing with coral reefs. There's not just horizontal zonation, but there's vertical zonation as well. If you go from the surface deeper and deeper into the sand, it gets wetter, it's less prone to drying out, and so it doesn't extend really deep into the sand, but there's vertical zonation in the sandy beach as well as horizontal zonation. So the sandy beaches, we love sandy beaches. You like going to the beach. There's big sandy beaches in Rhode Island and up and down the U.S. East Coast and a lot of places. So it's a very common ecosystem that lines the shore of a lot of continents, a lot of islands, the sandy beach ecosystem. Now, back in the day, we had a field trip to the sandy beach in this class, and they would look at zonation. They would examine the sand for different organisms and look close to the water and all the way up farther away from the water. Doesn't matter. Since we're not doing any field trips this semester, you can go to the sandy beach. You've probably gone to the sandy beach and appreciate this for yourselves the next time you're there. But this is a soft sediment, nothing to attach to. So there aren't a bunch of things that mollusks and algae and things that rely on hard substrate to attach to. There's a lot of burrowing things. So there's a lot of these invertebrates that we looked at earlier. There's crustaceans like amphipods and crabs. There's annelid worms, polychaetes. There's echinoderms like sand dollars, and there are other crustaceans, crabs, clams. People go to the sandy beach and dig for clams a lot of the time. So how are you going to live in a sandy beach? Well, you can live on top of the surface. You can be a burrower and come out and run around or crawl around on the surface like a lot of crustaceans do. Or you can stay burrowed in the sand. So there's epifauna that you see sometimes when the tide goes out. You see things that are moving around on the surface. They come out. Sometimes when the tide goes out, sometimes when the tide comes in and there's water, that's when they come out. So it depends on what your lifestyle is. And then there's a bunch of infauna, and this is what would be interesting if you were at the sandy beach and digging down there. You know, you dig holes and you bury yourself and you make sand castles and things like that. Very common. People are doing that all the time, but they're not paying so much attention to the organisms that are found there. And there's, as you go deeper and deeper, you know that you run into water, and it's wet, and organisms there don't have to worry about desiccation as much. So there's both of these levels of zonation, degrees of zonation, vertical and horizontal, in the sandy beach. And here, somebody sitting up there by the grass, very dry, and it doesn't get underwater very much, and you can see the water out there in the distance. Very different environment out there. So you see clams, you see worms, you see segmented worms, and you see a lot of crustaceans. And you go make this transition from where it's very dry and you're hardly ever wet, hardly ever submerged, closer and closer to the water, where you're submerged almost all the time. So this is the type of zonation that you'd see. On the left is water, and if you're underwater all the time, you can be a fish, you can be a cucumber, you can be some mollusks. And if you're out of the water and you can tolerate being out of the water, then you can be up there on the right. You can be a crab that comes out and runs around. You can be a polychaete worm, an amphipod. Some mollusks can tolerate being out of the water. And so this is the type of zonation that you see horizontally, moving from the water to shore, which is similar. This zonation pattern that's a combination of the biological and physical features that you see in a number of these intertidal ecosystems. Well, let's look at the rocky shore. There are quite a few rocky shore ecosystems. In Rhode Island, we've got a few, but it's along the whole East Coast. It's not the most prominent type of shoreline or intertidal ecosystem. If you go up farther north, New Hampshire and Maine, then there's a lot of rocky shore. There's some in Rhode Island. We had a field trip going to the rocky shore. But on the west coast of the U.S. and other parts of the world, there are a lot of shorelines that are rocky, and you have this intertidal ecosystem that you can get to easily. You don't need any special equipment to study it. There's vast expanses of these rocky shores, so it's really a well-studied ecosystem as far as the intertidal ecosystems. And in some ways, this is probably the best studied intertidal ecosystem, these rocky shore. So let's look at the rocky shore, and we'll spend a lot more time looking at this. There's a lot more information. It may not be our big coastline ecosystem on the East Coast, but we do have them in other parts of the U.S. They're on the West Coast especially, a lot of rocky shore. So we'll look at these four different aspects of rocky shores, rocky shore intertidal ecosystems, with a focus, as we'll see, being this zonation. This is where zonation can be very well illustrated. It's well studied, and it will illustrate this point that I've been making all along, that zonation is quite common, one of the major themes of intertidal ecosystems. So if you go around the world, maybe not on the U.S. East Coast where there's a lot of sand and this low terrain, but around the world there are a lot of rocky shores. 75% of world shorelines, especially in more temperate areas, but even in the tropics, there's a lot of islands, there's a lot of coastline rocky shore. That's not suitable for mangroves, and it's not suitable for these other intertidal ecosystems. You don't have big sandy beaches. And so if you think about the rocky shore, what's going on there? You've got the water crashing, the waves crashing on the rocks. You've got this hard substrate. You can't burrow into that can't be your way of life, being a burrower and then coming out. You've got to stick to the rocks somehow. You've got to have some mechanism for attaching to the rocks. There isn't this vertical zonation. The rocks are hard. You can't burrow into the rocks. It's a flat surface. And so there's a large degree of competition to be able to attach yourselves to the rock, to carve out some little niche for yourself, whether you're an algae, or whether you're an urchin, or whether you're a starfish, or whether you're a barnacle or mollusk or a mussel. You've got to attach yourself to the rocks. You've got to be able to tolerate waves crashing there. So on the U.S. West Coast, very extensive rocky shores. On the U.S. East Coast, not so much, but if you get up north of Cape Cod, as I said, especially up in Maine and up into Canada, there are a lot of rocky shores, a lot of rocky shore intertidal coastlines. So let's talk for a minute about what you need to do to be able to tolerate these conditions, or if you're not tolerating them, then what kind of conditions you experience that lead you to not be able to live there. Well, the water comes up, you're underwater. The water goes down, you're out of the water. The tide goes in, you're really a marine organism because you're in the ocean. The water goes down, then you're more of a terrestrial organism. So you're exposed to heat. Out of the water, temperature changes a lot more drastically than underwater. You're exposed to desiccation. If you're not underwater, then you're losing water, first of all. You have to exchange gases out of the water as opposed to underwater, which is easy for invertebrates to do. You've got to osmoregulate out of the water. So there's a lot of environmental challenges for being a rocky shore intertidal ecosystem inhabitant. And different than these other intertidal ecosystems that we've looked at, you've got to deal with waves crashing, strong water movement. And so if you look at the shape of these, you've got to be able to dissipate the pressure, the force of these waves hitting you. And so a lot of organisms have shells that are designed to do that. But basically, if you look at a lot of these intertidal organisms that are in the rocky shore, they have some ability to withstand wave shock, to withstand desiccation, and to withstand these drastic temperature changes. And in addition to that, you could put a fourth thing up here, which is tolerate drastic salinity changes that occur sometimes. So what do these organisms do to be able to tolerate this? And if you look in Australia, you look in South America, you look on the West Coast, you look in Asia, you look in Europe, all different species, but they tend to have these same mechanisms, these same characteristics for dealing with those environmental conditions that are experienced in the rocky shore. So what do you do for overheating? Well, you have a body shape that dissipates heat. You've got a operculum a lot of time. You've got some mechanism for conserving water. You have you can close your shell basically and keep the water in your shell when you're exposed. When you're underwater, it doesn't matter. You can open your shell. You can be fully exposed to the water. So in terms of the surface area, it helps in thermoregulation, and these little protuberances that stick out that act kind of as radiators. Desiccation, if you can close your shell, you can conserve water. Some of these have antifreeze compounds. If you close your shell and you're full of water, that also helps to mitigate temperature changes, because the water in your shell and in your body is going to change temperature more slowly than the air. And then in terms of tolerating waves crashing on you, there's all these different shapes of shells. To wave hits and it dissipates the forces of a crashing wave hitting on you. You've got tube feet, or you've got some kind of a suction material. You've got byssal threads. You've got some mechanism for attaching to the rocks. You've got a hold fast if you're talking about algae. And then in terms of salinity changes, let's say you're in a part of the rocky shore intertidal ecosystems are tide pools. If you're in a tide pool, then the tide pool, the water evaporates and it becomes hypersaline. It's really salty and you've got to tolerate that. Let's say you're in a tide pool and it rains. Now you've got this influx of fresh water, and this little pool that you live in is becoming more and more dilute, more and more fresh water. Unless the tide comes up and replenishes the salt water in the tide pool, which happens a lot of times, but not all the time, then you could be experiencing these very drastic changes in salinity. This is an intertidal ecosystem, though, these rocky shore. So the degree to which you're underwater, out of the water, the degree to which you're faced with waves crashing on you or desiccation, whatever the challenge is, the degree to that variation is quite variable depending on where you are. In Hawaii, there's very little tidal amplitude. It's hard to tell when it's high tide and low tide. In Rhode Island, there's intermediate high tides and low tides. There's certainly times when you can look at the tide table and say, this is a good day to go to the rocky shore. This is a good day to go and look at tide pools because you have this extreme low tide. It's going to be a lot better for looking at things that are exposed. For classes and organizations that are taking field trips to the rocky shore in these tide pool ecosystems, they look at these tide charts all the time, the tide tables, and they say, okay, we're going to go at 9 o'clock in the morning on Wednesday, March 17th, whatever, because that's when there's a low tide. If you look at the Bay of Fundy, these really, really high amplitude tides, some places near the equator, there's a big tidal amplitude. So it really depends where you are, but regardless of where you are, you've got some high tide and low tide that you have to deal with. Another thing in terms of the rocky shore are these, you're in the water and you're out of the water. Underwater, as I've said, it's an easy way of life. You don't have to deal with much. You're underwater. There, you can feed, you obtain oxygen, you don't have to worry about osmoregulating. But when you're out of the water, now that's an extreme set of conditions that you've got to deal with. And so this is the whole point of this zonation and the interaction of physical features and biological features. If you look at the percentage of exposure, this figure shows the percentage of exposure in these different areas, different distances away from the water. So you move farther and farther away from the water in the rocky shore, then the percentage of time that you're submerged, that's what this figure shows, becomes less and less. The farther and farther you get out of the water, obviously, the less time you're going to be submerged. So there's organisms that are up in the right-hand corner of this figure that are hardly ever underwater, and then there's a lot more organisms that are underwater almost all the time. And then when you get down to the lowest low tide, then you're never out of the water. In fact, you're not really, technically, you're not in the intertidal anymore because you're underwater all the time. You're never exposed. So those are the kind of conditions that intertidal organisms, and especially those that we're looking at right now, rocky intertidal organisms, experience all over the place, whether you're talking about the English coast, the U.S. West Coast, Hawaii, Rhode Island, or Nova Scotia. Now I want to focus our attention on the zonation that you see in the rocky intertidal. Well studied, well documented, a lot of information. You can imagine how easy it is. People all over the world with little funding, little means for transportation. You don't need a boat. You don't need any special equipment. You can walk there, walk around, and document all these different things that are going on. You can manipulate things. You can take all the snails out. You can remove the barnacles. You can gather a huge amount of information about what's going on there in terms of the organisms. You can study their physiological responses, their physiological traits. You can study their morphological traits. You can do a lot of ecology. And so all this information that's available for the rocky shore exceeds what's known about some other intertidal ecosystems. And especially in terms of zonation, this will be a good demonstration of what you see in a lot of intertidal ecosystems. So for the next lecture, that's what we're going to look at, is zonation in the rocky shore.